As per the question, thorium undergoes disintegration to form lead. Mass number of thorium is given as 232 and that of lead is 208. Atomic number of thorium is 90 and that of lead is 82. We know that when an alpha particle is emitted, mass number decreases by 4 and atomic number decreases by 2. When a beta particle is emitted, mass number does not change, but atomic number increases by 1. That means mass number changes from 232 to 208 due to the emission of alpha particles only. Beta particle does not contribute anything to change the mass number. 232 minus 208 is equal to 24. For the decrease of mass number by 24, how many alpha particles must be emitted? Since the emission of one alpha particle can cause a decrease of mass number by 4, in this case 6 alpha particles are emitted. But by the emission of alpha particles, atomic number also decreases. If 6 alpha particles are emitted, atomic number should have been decreased by 6 times 2, that is 12. But in this case, atomic number decreases by only 8. This is due to the emission of beta particles. How many beta particles are emitted? 12 minus 8. So, when thorium 232 disintegrates to lead 208, 6 alpha particles and 4 beta particles are emitted. If you want, we can approach the question in a different way. Listen. Let the number of alpha particles emitted be N1 and the number of beta particles emitted be N2. Now consider the case of mass number. The emission of one alpha particle results in the reduction of mass number by 4. So here mass number decreases from 232. So we can write 232 minus N1 times 4. This mass number does not change by the emission of beta particles. So we can write N2 times 0 That is 0 only. Okay, we can ignore that. Well, so 232 minus n1 times 4 equal to 208. So on solving, we will get n1 is equal to 6. 6 alpha particles are emitted. Now let us consider the case of atomic number. By the emission of an alpha particle, atomic number decreases by 2, and by the emission of beta particle, atomic number increases by 1. Here atomic number changes from 90 to 82. So it will be 90 minus n1 times of 2 plus n2 times of 1 equal to 82. We have already found the value of n1, that is 6. On substituting the value, our equation becomes 90 minus 12 plus n2 equal to 82. Thus n2 is 4. When thorium disintegrates to form lead, 6 alpha particles and 4 beta particles are emitted. This is assertion and reason type question. Let us say number of protons in a neutral atom be x and the number of neutrons be y. Then what will be the number of electrons? Number of electrons will also be x, because in a neutral atom total positive charge must be equal to total negative charge. What happens when nucleus of this atom undergoes beta decay? A neutron releases a beta particle and changes to a proton. So after beta decay, number of protons in the nucleus will be 1 more than the previous value, x plus 1. And the number of neutrons will be 1 less than the previous value, that is y minus 1. What about the number of electrons? No, number of electrons in the orbit does not change. Thus, mass number, that is the total number of protons and neutrons, remains the same, but net charge of atom is not 0, as the number of proton is not equal to the number of electron. So the answer is assertion is a wrong statement, but reason is the correct statement. Question 1.3. It is easy for you to identify the radiations represented by B. Since these radiations are not being affected by magnetic field, they are nothing but gamma radiations. So the answer would be either option D or option B. Now our work is to identify if A is alpha or beta particle. For that, we need the help of Fleming's left hand rule. The rule says if we stretch the forefinger, central finger and thumb of our left hand mutually perpendicular to each other such that forefinger indicates direction of magnetic field, central finger indicates direction of current, then thumb will show the direction of force applied on the particle. In this case, particles are moving towards right, If they are positively charged particles, direction of current is towards right. Apply Fleming's left hand rule to find the direction of motion of the particle, and you will see that it is upwards. But in the question, these particles are bending downwards. That means direction of current is not towards right. For the downward deviation of the particles, the current must flow towards left. Thus, direction of current flow is opposite to direction of motion of the particle. That is possible only if the particles are negatively charged. Yes, they are beta particles. So the answer is D. Question 3. There are 3 atom diagrams. Atom diagrams. The number of protons in an atom is equal to the number of electrons. So to find the number of protons in the nucleus, just count the number of electrons. So in diagram A, there are 3 electrons. In B, there are 4 electrons. And in C also, there are 3 electrons. So number of protons in the nuclei of A and C are the same. On close observation, you will understand that they are the isotopes. In part B of the question, we have to identify the positively charged particle. Filled circle is the proton and it has positive charge. Part C of the question is to draw an alpha particle with the same symbols. Here it is. Two protons and 2 neutrons constitute an alpha particle.